Okay, this video is going to be about temperature conversion. So we're going to be under our first tab, and we're going to be on this left-hand side. I do want to show you this up here. That is from the state, and that's the conversion factor list that you will get on your quiz, your test. That's what you can use on your homework. So this is pressure and this is temperature. So this is the conversion or the equation we're going to use for these temperature conversions. K is for Kelvin. Kelvin is a measure of temperature where there is no negatives. So in theory, 0 Kelvin would mean that there is no particle movement. So it's a theoretical number. We've never gotten there, but that is what Kelvin is. That's what you're going to need all of your temperature units to be as we are doing the math for gas laws. Celsius is what we're more used to seeing. I know here in the U.S. we're used to talking about Fahrenheit, but in science world we use Celsius. So we're only going to be dealing with Kelvin and Celsius, so this will be the only equation you need. We will not be converting to or from Fahrenheit. Okay, so let's go ahead and take a look at this. I'm going to write our equation at the top here so we don't forget it. It's Kelvin equals degrees Celsius plus 273. So let's jump into some examples here. So we are saying 273 Kelvin, so I'm going to put that in for my K. I don't know my Celsius, so I'm going to put an X plus 273. I need to get X by itself, so I'm going to subtract 273. And I get 0 equals X, so I'm just going to put 0 there. Now there is no way to make 0 have sig figs, so I'm just going to write 0. Let's check out our next question here. We're still going to plug our Kelvin in, X for our Celsius, plus 273. I'm going to subtract 273 from both sides, and I end up with negative 66. Now, we have a ones place, so that can be significant, so I'm not even going to have to change this number. So you'll notice for Kelvin to Celsius, I'm always subtracting my 273. So Kelvin to Celsius, I'm going to subtract. So if we're doing the opposite of that, we know right here that for Celsius to Kelvin, we're going to add our 273. So you can either remember those rules or use that equation either way. So we have our X for our Kelvin, 25 plus 273. We end up with 298. Because we are adding, we have those ones places, so I know that I can have a significant digit up to that point. So I'm good with my number there. Let's check out this next one. Put X in for my Kelvin. 40 plus 273. That's 313. Now you'll notice that this 0 is not significant. There's no decimal place there. So I cannot have anything in my ones place. So I'm going to have to say, what does that 3 do to that 1? Nothing. So my answer is going to be 310. Now if it was something like 40.2 degrees Celsius, I would have to say X plus equals 40.2 plus 273 equals right there. So X would be 313.2. Well, I can't go past my ones place, so I'm going to have to round this. What does that 2 do to that 3? Absolutely nothing. So 313 Kelvin. So watch out for your sig figs there as we work through our gas laws problems. Whenever you are converting from Celsius to Kelvin or Kelvin to Celsius, you're going to have to sig fig that before you go on to do the other math because they are different sig fig practices. So we're adding and subtracting here. So remember, we're looking at place values.